definitely know any contribution follows the IPR. As the participant, you follow all of its rules, uh, and you agree to deal respectfully with your colleagues here. Anything you missed, please see the details. Okay, the agenda is before you. We will make one alteration. Linda has a presentation in another working group, so she will go second prior to the BFD, to the BGP FISM. Chair, and then we have 11 speakers. We are pretty tight on time, but we do want discussion, so I will try to trim some of the chairs. Chair's topics are document status. There's been a lot of document status. I have put things online. There is a couple places where this is, I may have a previous slide. Lots of you submitted drafts this morning, 3 chairs like Ketan and other people. I will catch up with the status, and we have early allocation. And then I'm going to give a quick report on the FlowSpec V2 interims. This FlowSpec V2 interims will be covered on Friday, but some of you may go home, so I'll give you a high-level overview. Okay, what's in working group last call or awaiting the AD review? There is one draft in working ITF last call. That's the send hold timer. It ends 7/27. We're waiting AD review on 4 drafts. You can see here the length of time that it sat there waiting for the AD to get to it. CAR and CT have been sitting for 87 days. CPR, which is another one of the CAR CT CPR discussions, they've been waiting for 87 days. We're waiting the Shepherd's review on SD-WAN, and we got a revision this morning for SR policy SAFI, which should hopefully start to clear up that awaiting. We're also awaiting spring adoptions under draft ITF IDR CTSR v6. Working group last calls pending. There is one added, looks like I got it this morning. The VPN prefix ORF. I'm giving the short forms with the last portion of the name. If you want to hear draft ITF on all of them, I will do that. So raise your hands and I'll do that. But otherwise, I'll give you a shortened form, which is the unique portion of the name. The draft VPN ORF, Kayer did a great Shepherd's review, and the authors have posted a revision. He'll review that, and then we'll head into working group last call. G is reviewing draft ITF IDR RT derived community, and the draft ITF IDR BGP FISM IANA is waiting for the discussion we're having today, along with the BFD strict, which is the 120 discussion in both IDR and BFD, and the draft ITF IDR BGP LS SR policy 05 that Ketan uploaded last night. I will review and send out discussions. Now, we have adoptions ending at the end of today. One is the draft HARES IDR FlowSpec V2 IP Basic 02. I've uploaded in 03. We're having an ITF discussion on Friday in order to clean off on that. I'll give you, if you would like to give us details, please do. The draft Sangli IDR BGP generic metric is in the middle of middle of adoption call. It's going fairly well, but we still need some more comments. And the draft PANG IDR segment routing TE policy attribute. We've taken a new approach to adoptions. We're starting to target them by groupings. So we had in the last period a BGP-LS SR interim where we covered those drafts, and what you receive as an author of those pre-adoption drafts is you receive a Shepherd's review before the interim, discussion at the interim, and post-interim action items, after which we're going through with adoptions. we've also broken in other functions such as the BGP base or new attributes or new community. So we're hoping that'll speed things along. This is a set of updates on the 4 drafts we had for BGP-LS SR. We took one of those already off the list. That is the draft pane draft that you saw earlier. We have pending adoptions for chair reviews. If you're in that status, Geng Yutaro, Abris, Wang, or Mishra, those groups of authors, please talk to the chairs if you have some concerns, but we're in the middle of reviewing those. Lastly, early allocations. We have 2 outstanding for John. One is the draft ITF BGP Inter-AS Topology 16. We would like John to review that. It's been sitting there, John, for about 5 weeks, so we'd appreciate some attention. And we're working this week actively to complete the draft IDR 5G Edge Service metadata. Looks like I left out the S there. Thanks to Jeff and I, we were the shepherds reviewing it. We expect that to be done and then go off the designated expert. There are 3 drafts holding for the publication of draft ITF IDR SR policy SAFI. If you're those people, we're working with Diana to see how we handle that. But right now, the best I can do is sort of suggest that you keep in touch with us, because you can't get an early allocation from a registry that's not yet created. Now, any questions on draft status? Okay, I think I did that fairly quick. I'll try to do the rest. May take us. I may be at 15 minutes and actually minus on our count. Flow spec V2. We had a number of interims that were working interims, meaning we were hoping for a lot of discussion and participants to talk about how we needed to break the big flow spec V2 IDR draft, which is complete and useful, but the implementers said, could we have it broken up into chunks so that we can implement a little at a time? Why did they want this? Because we require 2 implementations. That's a good, sensible thing. The basic IP flow spec for DDoS is a minimal subset plus that just carries over the V1 actions and filters and a user order. The second one is more filters. We looked at the same thing, only trying to add dependency between filters. That's still in discussion, and we need some feedback, because people say, well, I'll give you an example of that. Maybe you want to set DSCP and trait limiting and then redirect it to another port. So you might be able to handle a denial of service attack and send it off to a post processor. If you do them in reverse order, redirect, you're not going to get to the DSCP setting or maybe the traffic rating. The new actions for Team 3 are really looking at how to extend and make consistent the extended community actions and add what we used to call wide community actions, but it's really the path attribute, the community path attribute, and to add an action change. Again, I gave you the example of an action change earlier instead of a filter change. Filter might be, I want to look at TTL and then IP destination and then source address. My apologies for swapping them. And then you have a plugin for L2 and other things. Okay, that tells you that it's a split and how the split goes. The IP basic has the minimal subset. The second one looks at the extended filters. The third and the filter chains, TTL plus something else. and the last is the action. We will continue to discuss the last two. The purpose of the breakout in draft hairs, flow spec, V2 more IP filters is to do the general work of handling filter chains uh, and then work on a template. The same sort of thing is due for the IP actions. You will have a general concept of what is a chain of actions, set a DSCP bit, then set rate limit, then something else. Um, and the last will deal with the non-IP, such as L2. What this is proposing, if you have flow spec V1 drafts and add an ID, what we're asking for you to do is to create both a flow spec V1 and V2 draft if it's deployed. If it's not, please use V2 templates. That was a decision made 3 years ago by the working group. Okay, now I'm just listing drafts. Why in the heck are we doing this? Well, if you look at the listing of drafts there, we have a whole bunch of proposals for filters. We have a whole bunch of proposals for actions doing redirect, marking, and we have a whole bunch of non-IP. So we're trying to categorize it, divide and conquer. Okay, Friday we will go through that in detail, and hopefully I have given you what we're doing. A couple new ideas. Should we have packet filters as well as linked data? Example of linked data might be color, because you might use that to go to a particular VRF. And Jeff asked a question, so I put this in thing. Should we make component IDs global or local to the type? The type would be IP extended filters, L2 filters. I've given you a global thing. Again, we'll talk about that. And with that, I've managed a little over my 10 minutes. Any other questions about status or our interim status? Please, if you want to talk about FlowSpec V2, come talk to me. I'm the chair herding that work. Okay, next we will go with Linda. Give me a moment, Linda.
Okay, so I'll just give a brief update of the major changes to the 5G metadata pass attribute draft. Um, so just rehash for people who haven't read it yet. I hope you go ahead to read it. Pass attribute is a new non-transitive pass attribute to carry some metadata related to services attached to egress router. And just bear in mind, there's only a few prefixes need to attach the pass attribute. Those services are like low latency services for edge computing services. And there's a GitHub issue tracking, and for people who have issues and who want to propose some new features, comments, please go ahead and go to the GitHub to put your new requests in there. So since IETF 119, we just added a new sub-TLV called AS scope sub-TLV added to the section into the propagation and scoping the propagation is mainly to prevent unintended leaking to ASs, which are not supposed to process them. Even though we had to add the non-advertised community into the pass attribute, but some routers may drop them. So the AS scope sub-TLV is attached with the pass attribute, basically list down in scope AS.
Linda, maybe you want to speak a little louder.
Okay, is that better? Okay. So there's a checking procedures for mismatch checking in the document, which is just uploaded today. I hope people can have a look of that. That's the new subsection added. Basically, if a router received the pass attribute and the rec cannot doesn't recognize the AS value, it should drop the pass attribute, not propagate to other routers. There are some other changes from the mailing list and the GitHubs. We moved this, there's a section explaining how does ingress router process the pass attribute passed in. It's mainly for illustration of why we need to pass those attributes. So that's moved to the appendix. And we added all the, explicitly added the SAFIs, which can attach pass attribute. We added a section on the route churn consideration because you don't want the ingress router to change route very quickly, cause issues, even though the service metrics may change value quickly. And for the security consideration, as I mentioned earlier, we make sure the route reflector will add non-advertised community and it's set as non-transitive. There's one discussion point, I think Jeff mentioned at last IETF about constraining the propagation because not all ingress routers are capable of considering the service metrics. So for those routers, they may not need to receive the pass attributes. So you can use IFC 4684 to indicate the prefix that you're interested in receiving so that route reflector can prune those ingress router who are not interested in receiving the path attributes. Currently we're using SAFI 132, which is allowed in IFC 4684. So Jeff mentioned that we may apply a new SAFI. So we would like to hear the working group feedback on that if it is necessary. Here's the list of INI registry we needed. The most important is the early allocation for the pass attribute. And underneath this pass attribute, currently we have defined 7 sub-TLVs. So that's it. We hope to hear more feedback and they would like to have early allocation for the pass attribute. Thank you.
Any questions for Linda? Okay, Fiza.
Okay.
Good morning, everybody. This is a reminder to please scan in on the QR code if you have not done so. We use this to actually make sure that we get rooms that are big enough for all of us, and we'll make sure that actually continues to be the case. So we're going to have a set of presentations back to back discussing things related to BGP finite state stuff, which seems terribly unexciting. BGP version 1 shipped in 1989 as I was graduating from high school, and the state machines that are inside of it have gone through different levels of revision over time. Some of the details we'll talk about in this presentation have been very stable over the course of BGP. And what we're finding is as we're maintaining the protocol, especially as we start adding more intrusive features, that getting these details right is itself not necessarily hard in the code, but getting the details correct in the specifications is challenging. And so you're going to have to lead focus on here so I can click. There we go. Back up. So as I mentioned, it's been about 30 odd years for BGP at the moment. BGP 1 did actually specify the state machine, and BGP 4 is where we've been in our current 6 states of how BGP actually works right now. starting in the effort to actually put out RFC 4271 around draft 17 of very many drafts, we added a bunch of stuff related to the FISM for a lot of internal states at the request of the AD at the time, Alex Zinnen. And this is because we actually had some implementation interop issues that were being observed in the field. 4270 is what we actually shipped that gave us the current set of things. A couple of details overlapping terminology. So the BGP state machine is largely in the form of a Moore state machine. Its transitions are based on a set of inputs and don't depend on prior inputs. 4271 doesn't have anything that resembles substates, and that's an interesting set of choices that we made at the time. We kept the original 6 states that BGP started with way back in the day, primarily because what we observe is that these are roughly corresponding what happens on the wire as BGP executes a state machine to come up. That said, there's a lot of things tied to what we eventually called session attributes that represent some internal state, and some of the events that are getting generated in there are based on something happening well given that variable is effectively true or false. So pick examples of things that probably could have been represented using substates. Timers that are running is an example. That can be represented or not as a variable. The delay open feature, which is implemented by a significant number of implementations and is actually one of the original sources of a lot of problems for sessions coming up. TCP state tracking. We have to do some level of this no matter what to just say things like graceful restart, sessions that are running in parallel. Session collisions are another example of something that is effectively multiple instances of the state machine needing to cross-communicate with each other. And the same thing's also true for version negotiation. And these details about how multiple state machines that are existing in parallel interact with each other is left a little bit vague even in the current RFC. One of the things that we spent almost no time in there dealing with, which has impacted maintenance of the protocol, has been what happens when we're in the established state. We just say we get this established, we've done multiple pages of this very complicated FISM, only to have the actual interesting pieces of the protocol not really get talked about at all. For our state transitions, we again have largely a current state. When we actually get an event of some sort, which might be decorated by some attribute, we'll have a transition to the next state. One of the things that we have chose to do in 4271, which is the source of a lot of the churn and most of the textual noise in the RFC, is we chose to represent the actions that take place as a block of text that may be repeated. And this repetition is where some of the errors got introduced in the RFC. This includes actions like sending PDUs, setting or clearing timers, changing session attributes, and of course the state change itself. For the actions, like I said, there's a huge amount of redundancy in there. That was a conscious choice at the time, and what we found is that that's actually a source of the maintenance headaches that we have in the current format that we're defining in the RFCs right now. And this is maybe our opportunity to start re-examining this sort of thing. One of the things that we do have as a problem is that when there is redundant text, this means that sometimes over the maintenance of the text, errors have crept in. So we're having this conversation because we're talking about maintaining things in BGP where the state machine is being involved. So from a black box perspective, as I mentioned, these 6 states that we have are basically taking their transitions on standard BGP events, based on stuff on the wire, open messages, notifications, keep alive. The internal states that we're actually doing, we didn't really talk about what's happening inside the machine terribly well. So the question becomes effectively what happens in terms of substates. And if we choose to manifest these things, the big 6 states we have right now show up in the old mid module, show up in the current Yang modules, both IETF and OpenConfig. If we're adding substates, we're going to need some level of management exposure of these things as well, which means some level of standardization for such things. Maintaining the text itself, as I mentioned, is a challenge. The style that has been used and given the blocks of the action text is here's a block of old text, here's a block of new text. It makes writing diffs effectively very hard. IETF is a patch culture, and as a side effect, if you support some different sets of a given feature across a given vendor, given implementation, it's very tricky to know how the patches sort of line up. You may have a conflict effectively. So in terms of consistency, we have a small number of things that absolutely have FISM impact that were different levels of success in terms of clear about the changes. BGP graceful restart, did actually talk about how things were actually impacted. It impacted TCP state tracking. It talked about whether or not we release resources, as we were talking about in 4271 or not. We have outbound route filters built on top of route refresh. And a consequence of that is you basically enter a substate where you're learning the rules for your filter. And once you've accumulated the rules, a refresh operation executes them. This is all happening inside that giant black box called establish that we don't talk about very well. And very similarly, the enhanced route refresh feature does similar types of substates. We're having this conversation because we're actually changing things, and we want to actually be a little bit better about how this is done. And we've gotten a lot of more scrutiny on this because people that pay close attention to detail, working group members like Ketan as an example, are drawing our attention to there's things that we're not discussing in appropriate level of detail. The places we've seen this is in the most recent send hold timer work. Very small change set of things, but it caused an awful lot of discussion. It was hundreds of messages over this thing, much to the disheartened authors that are working on the feature. The BFD strict mode feature, again, that's doing some similar types of things. We'll be discussing that a little bit later. The BGP quick proposal is making significant changes to how BGP sort of works for individual pieces of detail, while trying to keep a very broad brush equivalent of how BGP sort of looks today. How do you document the differences? How do you actually document how the different substate machines work? Those are going to be part of the upcoming presentations. And sort of finally on this sort of thing, there is potential work that we're looking at to actually take BGP to full standard. This is our chance to basically reevaluate the maintenance choices we've made inside of the protocol and decide if we want to change how they're documenting. So in terms of making things maintainable, like I said, even though we're doing more state machines, there are things that we're doing that are on impact or on input that are part of events. This is not quite a melee style state machine if you're a finite state machine formalist. Things that we can do that sort of help us, especially for BGP specific procedures, when we have common actions, we can basically build templates for these things. This means that it'll be a lot easier for us to see when there's commonality of a set of overlapping actions, you're doing the same thing in various places. This also gives us the opportunity to chain actions together such that a template one can have an additional action added to it. This sort of enables our patch culture to maintain these things more successfully. And the pending operations we're looking at probably will make documenting the transitions for future extensions better. Stylistically, we're still very much in trough style RFC stuff. The text forms have gotten better, but they're still not great. We do actually have some ability to do better in some places through the current RFC tools. As an example, we can split things into sections in a more clean fashion. The FD strict does this. In the HTML formats, we get the ability to do markups such as block quotes and emphasis on various things to make the diffs easier to read. And finally, we're also looking at, can we use UML both in textual format and graphical format, which we'll talk about in the upcoming presentations, to actually put the state machines in more human readable format inside the RFCs themselves. I think that's the last slide for this part.
Yep. We should go right on to the next.
Yep. So having given the introduction, we're going to talk about the BFD strict mode feature. This is a brief update relating to what we've changed. And just as importantly, some of the impacts on FISM maintenance and things we're looking at.
Just give it a couple minutes. It's got to tell us you're not on the same deck. Go ahead.
Yeah, you have to leave focus on the window.
Okay? I
Sorry,
don't,
I'm just going to ask you the next slide.
I'll do this. Go ahead.
There we go. So
You should be able to use the clicker now.
I'll try one more time.
Yep.
Okay. So brief reminder, what is BFD? Bidirectional forwarding detection, which I happen to have the joy of being the chair of for 20 odd years, is a very lightweight hello protocol that basically says these two systems are able to talk to each other. We've been using this fast mechanism to augment other protocols to fail fast. That's its only job. Tiny, tiny protocol. We have a generic RFC 5882 that says, here's how you use BFD for things like control plane protocols. And for the most part, it's pretty dumb. Once the session goes down, take your thing down fast. That's all it really says. The headache that we have for any of these maintenance features is that we don't talk about when does the session for BFD go up versus the state machines for the other bits of the protocol. And the consequence that we've actually seen is that things mostly work, and much like 4271, sometimes you have edge cases where they didn't. And these are things that we figured out over time. As a consequence, what we've been doing is strict mode features across our IETF protocol suites. For the IGPs, ISIS and OSPF have strict modes, and BGP here also is adding a strict mode as well. What this does is it regulates when the BFD state machine goes up and how the BGP state machine goes up along with it. The problem is if they actually go up at different orders and one's waiting on each other, implementation A and implementation B could deadlock. And we're stuck again.
Try now.
There we go. Have you tried turning it off and back on again? So BFD strict mode is capability negotiated. If you both agree that you're doing this, you're going to follow a rigorous procedure between two devices. Very tersely. BGP should start its state machine before BFD goes up itself. So you don't deadlock starting BGP. Implementations might want to start the BFD before BFD actually, before BGP gets configured itself. This allows that anybody that has a slower BFD to actually start the process, so that it doesn't take too much time to come up. BGP doesn't transition to open confirm until it needs to send that final keep live until BFD itself goes up. This hasn't changed in a good long time. We're at version 13. What is the difference? Well, we've had a prompt from Ketan. It's like, look at the state machines as part of our various implementations. Did we get the details right? And the answer was no. When we sort of do the formal analysis, we were trying to say, if you're an open confirm, hold your breath before you actually send the keep live. That's not how the implementations actually work, and that doesn't reflect what the BGP states look like. So as a side effect, 13 says that we're going to add in substates for all the places where we would transition into open confirm. And we're basically now in a BFD pending state. This means we're going to have to change the documentation for the code and review our implementations to make sure that this is what we're doing. In terms of the on-the-wire observable behavior, nothing has changed. We also did the work to document that when BFD goes down, we take BGP down with it. That was written down nowhere. In terms of document status, we have early chair feedback on this. Please take a look at the comments on the list and add your own. Implementers need to make small tweaks to the code to actually impact display issues where those things now exist, and to verify against the state machine stuff that we've just spent our time working through. This is the time for the working group to take a look at these formal details, and ideally before IETF 121, tell us we're ready to go. As part of the modeling effort, and Yingzhen's going to do a much nicer job than my two pieces here. What's actually changed here? Well, here's an example of a subset of the BGP state machine representing the transitions strictly for BFD strict mode. So this is a way to visualize it. But when we sort of look at how do we represent our internal states? Well, as an example, if we add the delay open, that really is the motivation for some of these transitions. We're now actually exposing the fact that, well, delay open really is a substate itself. And as we start documenting these details, BGP Quick is an example where we've had to re-examine these things. We sort of see that there's some hidden assumptions that are getting exposed. and that UML is a nice way to actually help us debug these things. So we have time maybe for a brief question if anybody has one. Otherwise, we'll move on to the next FISM-related presentation. Okay, I think we're ready for the next one. That's right, I'm doing the first part. Okay, so Yingzhen and I are both doing this together. So again, this is both are overlapping the finite state machine, and very specifically, this is an update on the BGP quick work that we've been doing together, which Yingzhen has done most of the hard work on the finite state machine. She's now one of the 10 people on the planet that understands the BGP state machine very, very well. So a refresh about why are we actually talking about a BGP for quick? Well, it's not just running normal BGP over a quick stream. That's pretty boring. You can run BGP over pretty much anything that looks like a stream transport. What we're doing is we're actually trying to leverage the thing that Quick gives us, which as a core feature is multiple layer 5 streams. Why do we want to do this? Number one, the resilience model changes. We get the ability to actually use different channels in BGP where we can actually send address families down an individual stream. And if there's an issue in one of them, unlike current BGP today, we don't have to kill everything. And this is a significant issue for operators when there's just a simple framing error for the protocol. So we're targeting this for resilience. This also lets us solve the multi-session problem, where instead of saying, well, we can't bring up the new address family or whatever, we have examples of a feature for dynamic capabilities that implementers have found sort of an interesting set of problems. Well, we're addressing the issue a slightly different way by just simply saying you're allowed to run multiple instances of BGP as individual streams, since each stream is per AFI-SAFI. And this also allows us to handle our prioritization different in BGP. Individual AFI-SAFIs don't head-align block each other in the same way anymore. Other features that we're leveraging out of BGP Quick, Quick for BGP, is that Quick does provide transport security as a default bit of features inside of it. Minimally, this gives you a lot of the same properties you'd like out of TCP/AO or MD5 or almost IPsec. They're obviously not exactly the equivalent of security spaces. Go see your favorite security people if you want the deep dives on it. But that said, it also gives us features like certificates if they're actually useful. This is something that we'll be exploring in future versions of the document. A thing that we haven't talked about quite as much is that Quick supports connection migration. So if you have a circumstance, maybe in a data center environment where BGP, may be talking to some server and an instance of the VM needs to pop up and move somewhere else, you can allow that to happen without actually having to worry about, moving the address in exactly the same way. So a few terminology points. We have channels being sent over streams. What we actually care about for the quick connection itself is that on a individual quick stream, stream number 0 is the BGP control channel. This is where the protocol is brought up and down and how notifications are sent from one device to another. Everything else that we traditionally assume when that giant box marked established is a function channel. This is where on an individual stream in a unidirectional fashion, we allow BGP to send individual AFI-SAFIs. And since it's unidirectional, we can actually fail one direction without taking the other side out. So this is a nice actor diagram that talks about the usual way these things work. So on their control channel, pretend that's normal BGP for purposes of getting the box up. Some of the details here that are interesting that impact state machines are things like graceful restart. The box needs to know on a restart basis what individual AFI-SAFIs had been previously negotiated, because those are going to run on function channels, and you need to know to start the state machine for the graceful restart up front. But the actual work, as you see in the other diagrams, where we're starting individual address families, say for IPv4 unicast, HPLS, et cetera, are being run as individual instances on separate streams. So this is where we turn it over to the goddess of FISMs.
So if you do a search online, this is the beautiful diagram you will find that illustrating BCP FISM as defined in RFC 4271. So this picture does show you the big states, 6 state of the BCP finance state machine. It helps you understand the overall how it works, how it flows, how it transits from, from a state to another state. However, it doesn't give you all the details. If you want to see, like Jeff talked about, right, it doesn't show you all the sub-state. So what BCP FISM really looks like is something like this. Okay, obviously I'm not going to, like you figure out exactly what is which state, what the sub-state. This is too messy to look at. But that's really how BCP FISM works. And this one is actually the big, in the BCP over quick, we have the function control channel. Well, control channel, we have function channel. Control channel is responsible for set up the BCP over quick connection. So the finance state machine in the control channel is pretty much the same as the finance state machine defined in 4271. So that's include all the sub-state. That's how it looks like. So to give you some, something makes sense instead of looking at this, you don't even know where to look at diagram. So we can look at just connect state as an example. So here we included sub-state. The text in the right, the text box is actually the one I used to generate this state diagram. And at the bottom is an open source online tool you can use to generate this diagram. So here you, on the right, you can say I include sub-state like delay open hold timer. So how the state is, the event trigger the state transition also varies, depends on whether you have which sub-state you are in. So the number is actually the event number that defined in 4271 from 1 to 28. And for BOQ, we added 2 more events for BCP, for quick stream control. And that's the event. So
Yingzhen,
yeah,
are you assuming TLS 1.2 or TLS 1.3 with quick in these control channels?
yes. So for TLS 1.3 is the quick, that's part of quick definition. So for
But-
us, we are now changing that part.
So you're assuming TLS 1.3 for your
Yes.
quick.
Yes.
That might be useful to add in these diagrams.
Okay.
Meaning someplace in your document specify your quick
Yeah.
TLS version.
Okay. Yeah. Okay. So this one is the established state. So in the current version of the draft, we actually integrated BCP graceful restart 4724 also into the FISM, because that one changed the BCP finance state machine. In the established state, you can see the sub-state, whether your GR is enabled or not. That will, when you have a new TCP connection comes in, depending whether your GR is enabled or not, the collision, how you detect collision will be different. So I'm not going to explain all the details here, but you can take a look at the draft if you are interested, because the time limitation, right? So it's gonna take a long time to go into all the details. So the square bracket is actually the action that triggers after you receive the event. So besides not just the state transition, you probably also need to, for example, delete, if you are transition out of established state, you may want to delete your the routes you calculated or reset some timers. So, and these two are the state machine for the function channels, because function channels can only be started after the control channel already reached established state. So the state machine for the function channels are much simpler because we have unidirectional function channels. So we have a sending FISM and a receiving FISM. So the function channel always start from you just pretty much send an open message and start that opens the quick stream, and then you can start send the update. So for the sending FISM, we start from connect state directly. And for the receiving FISM, because it's always waiting for an open message, right? It doesn't actively send an open message. So we do, in function channel, for example, we don't have delay open anymore. That still works in the control channel, but not in the function channels anymore. So the overall, the FISM in the function channels are much simpler, but we do have them separated and they are different. So if you are interested, please read the draft. And okay, these are the actions. So I try to merge some of the very similar actions defined in 4271. I think they essentially mean the same thing, but the language used at some places are now very consistent. So we'll use this opportunity to try to clean up the language a little bit. And so right now in the draft, how the finance machine, that section is still following the 4271 style, but we are thinking, maybe later, somehow we can figure out a way to include those pictures in the draft, even in an appendix that may help people to understand. So this is a different. So end of rib marker, that's actually defined in 4724 for the purpose of BCP graceful restart. But even just in 4724, it's recommended because it's helpful for overall convergence. So for us, since we have a fresh start, we make this a normative language. We make it should always send end of rib marker to its peer. You can to indicate the implementation, the completion of the routing update. This way, it helps the routing convergence, and it also helps the overall performance. So. Not working.
Yeah, we're having internet issues.
Yeah, so I think that's all. So we have a GitHub repository. I can now move the mouse. Okay. Yeah, we always have the latest version of draft there. You can also track issues there.
I can make one final comment and then.
And now questions.
Yeah, so to throw in one comment before the questions hit. A couple slides back where Yingzhen demonstrated on her slide, the text that is used for populating the state machine, that is actually the input for a tool. One of the discussion points that IDR and maybe the rest of IETF may wish to consider is we have the options to potentially embed the state machines and along with the SVGs into the draft. One of the people at the mic has a nice RFC that actually has some very nice pictures of an SVG that may have additional comment.
Yeah.
Tony, we have 2 minutes for discussion.
Yeah, just a meta observation. Tony P. Juniper from dealing with this stuff quite extensively. This is a different level of complexity than like the initial toy machines, right? And pictures are nice, and the text is nice, and probably even textual tool may be nice, but in my experience, if you want this thing to be implemented and not cost years of interrupt problems and fixes and erratas, I would strongly suggest to write the reference implementation over a highly formalized finite state machine library. We can talk about this stuff, right? How this stuff looks, that actually generates out the pictures and the text of all the actions. from direct experience. Easy? No, but this level of complexity, otherwise it's extremely hard to manage it, because you have implementation, you have the pictures, you have the text, everything will start to go out of sync. I know Jordan is working on some tool. We talked about EBF and all the different approaches. If that stuff would be easy, it would have been solved a long time ago by researchers, right? And originally the UML guys also were on the illusion that you draw pictures and it generates codes, and that was one of the biggest abysmal, failures in modeling attempts. So maybe good offline discussion, but my observation is without a good reference implementation of an abstract library that generates all the stuff, you'll never keep the stuff in sync with reality. And people will just come off and do all kind of weird stuff you find in the field. Thanks.
Yeah. Thank you for the comments. Even for this tool, I actually tried several tools and took me several iterations. So I think so far this one looks the best to me. Maybe I haven't found the best yet, but this, we'll keep trying. But this 2 points, we will try to also commit. The text is actually the one used to generate this picture. So.
UMLET probably, right? It's still the best tool, I think. I have extensive experience with this kind of stuff. The problem, these things getting updated all the time, hard to keep them across the platforms. I live the dream enough as well. Yeah. Mm-hmm.
Agree.
Hey, Keyur Patel, Arcus, speaking as a working group member. This draft is pretty long, so I haven't reviewed everything. But one quick comment that I'd like to make is, if you look at Quick as a transport, there is a general pushback, particularly from stateful versus stateless security standpoint. So minimally, what you could do is augment and beef up the security section and put something in regards to that, and just beef it up, as opposed to just saying, hey, this runs on TCP, now it runs on Quick.
Yeah, I totally agree. So
that's a note to your past ADUs also.
So far this year we have spent so much time on this fantasy machine, so we sort of got lost there.
Right, you might also in the security look at the known TLS 1.3 issues and address that also as well. That was my reason for the earlier comment.
Yeah.
I mean, generally compliments. I mean, it's incredibly tedious, difficult work, right? So thanks for doing all the stuff. And it's very relevant. I think Quick is a very good candidate because of the multi-channeling especially, which nothing else provides. Yeah, thanks.
We have one from Shota. So we have one question online. Shota? Maybe. Okay, thank you for staying awake for us for Finance State Machines. This is interesting in somewhat an academic session, but it's actually very important stuff.
Shota, you can go ahead. Okay, it appears we have a bit of a problem. We'll go on to the next presentation. How do I stop this one? Just take it off. Where? Okay. He's off. Okay.
He's fixed it.
Hello, can you guys hear me?
We can hear you.
All right. All right. So this is an update on the extensions for supporting the generic metric for BGP. This is the incremental update, the one that we have given in the last IETF. My name is Srihari Sangli. I'm from Juniper. I'm presenting this on behalf of my co-authors. Next slide, please. Yeah, so it's going to be a short agenda. I'm going to provide a quick recap, talk about the updates to the draft, and then just talk about the next steps. Next slide, please. Yeah, so the problem is to provide end-to-end intent-aware path across multiple ASs. Today, RFC 7311 provides this capability, but it only supports the default IGP, which is the default IGP metric. Now that there is a need to provide end-to-end metric beyond IGP default, could be delay-based or bandwidth or any administratively defined metric types. The existing AIGP attribute cannot support. And if we try to extend this, we get into a problem with discontinuity. And it would be nice to have multiple metric types aligned with what the IGP registry develops. So what we're trying to solve is this problem. Next slide, please. So the proposal is, as we presented in the last IETF, we want to leverage the next hop capability attribute, NHC. As defined in the draft, it's a working group document. It's a optional and transitive attribute. It gives a nice way of providing a next hop level scoping. Accumulated metric is going to be carried within the NHC. And here's the format as defined in the draft. Specific attention is to the flags, which carry the different meanings for detecting or documenting discontinuity, or if normalized, what is the status of that. So next slide, please. The metric procedures have been defined in the draft more clearly. I just want to highlight a few things. Intent can be specified with more than one metric type. So the NHC can carry more than one metric information within it. And as the non-originator, when along the path, for each of the metric received, unlike the base NHC, which talks about reconstructing the entire set of content of the NHC, what we are asking is the non-originator router should retain the received metric and then update it. It is needed for accumulating the metric across the path by adding the cost to the next hop. And if it is normalized, update the flag. And if you're not able to understand the metric type, then we have to set the flags in the D bit has to be set to 1 in the metric flags. Next slide, please. Yeah, the discontinuity, just elaborating the types of discontinuity that can be seen in the network. The draft talks about the 3 types. If you're using NHC, then type A and type B will be automatically be detected depending on which router is upgraded to supporting NHC and which router is upgraded to support a metric. For the router that does support a metric, then the type C will automatically be detected because the metric flags will be set to the D bit in the metric flags will be set, and therefore all the different types of discontinuity will be deterministically determined with these procedures. Next slide, please. Yeah, in terms of best path computation, we could have the existing deployment with AIGP carrying the IGP default, and metric can also have the IGP default. So if they are the case, then they are comparable. On the other hand, if the metric has multiple different types of metric, just to break the tie, recommending lower metric type to win. And overall, the implementation can support a local policy to specify or override the preferences. Next slide, please. Okay, so here is where some of the discussions that happened on the alias. Regarding the discontinuity, first of all, discontinuity comes in because some routers are not upgraded, and therefore they don't support either next hop capability or the metric, right? So NHC is optional and transitive. So if the router that is originating this A metric gets advertised, and if the border router is according to the NHC draft, the border router must filter the NHC as well as the A metric if it is going to go beyond the common administration AS boundary. And this is one way of preventing the leak. And let us say it is not implemented, and because this is transitive, it gets leaked to the neighboring ASs. This is outside of the common administration, right? And the receiving peer, the EBGP peer, can implement a local filter on the incoming. Therefore, it can drop the NHC attribute. That's one manually filtered. Or if it is not done, then it will go within the neighboring AS until it hits ASB or some router that's going to be detecting the NHC. And given the NHC's next top level scoping, that attribute will be dropped on the floor. And this is how the leak is detected. And nevertheless, any router that's going to be analyzing the A metric will not be able to use the A metric because next top scoping will fail, and therefore A metric will not be used. Right. Now, within the common administration domain, just one couple, within the common administration domain, if you have discontinuous path propagated to the the ingress can figure out how to use those paths. Either it can discard or put a low preference if you have multiple paths. One is discontinuous, another one is continuous, or can use the type breaker. But the draft is recommending that all routers within a domain must use a metric because the best path computation has to be consistent unless you use tunneling to reach any of the next stops. Next slide, please. So all of these, what I presented here was discussed in the last IETF session. The work group adoption call is going on, and there are some comments. Any more comments that people have either now or on the list are most welcome. Just on the side, some people have expressed maybe capability as an overloaded word in the entropy label draft. This is just an request to the authors to see whether that name can be changed. I'm just proposing characteristics, but any other better word would be helpful. That's all I had. Any questions?
Keyur Patel, Arcus. A quick question. Speaking as a non-working, as a working group member, NHC is not transitive across ASs, particularly where the next stop is overwritten on an EBGP session. So how are you, I probably have missed this, but how are you incorporating AIGP equivalent matrix across ASs?
Okay, I may have misunderstood. This is transitive, but then at the boundary, the NHC is going to say within the ASBR or at the ASBR for the ABGP, it's going to allow the NHC.
Okay, we can take that offline. But my question was very specific across EBGP sessions where next stop are overwritten. That capability sort of cease to exist, and how do you then accumulate IGP matrix? But I can take it offline.
Sure.
Keaton, go ahead.
Ketan Taravlikar, Cisco. So to answer Keyur's question, so it is NHC is non-transitive. The text in the draft says it is kind of, it's not just sent across unchanged, it is reformed or repackaged or reoriginated is the term used. So even for example, entropy label in a multi-domain deployment where the ASs are under the control of the same provider, it does cover the mechanism for conveying the ELC.
Okay, that was my question.
Yeah,
But I think then that means is that an implementation has to enforce to that outside the scope of protocol, meaning it's more an implementation dependent thing where next stop flips but implementation has to carry that
Yeah.
NHT and do an accumulated
Yeah.
conversion and then send it, re-inject it.
It's the same for ELC as well.
Precisely like a non-transitive community is getting re-injected across ES boundaries,
Correct.
right?
Yeah, it's
All
the
right,
same.
super.
It's same for ELC as well.
Yeah.
That's right. Thank you, Ketan. Yeah.
Thank you, Srihari. We'll go to the next presentation. Cheng Wei,
Can you hear me?
a little bit louder, please.
Can you hear me?
Yes, we can.
Okay. Hi everyone, this is Chang Wanling from New H3C. I will present this draft. This draft is about the BP protocol extension of SR policy for composite candidate paths. Next page, please. So background, as described in RFC 19256, composite candidate paths act as a container for grouping SR policy. A regular SR policy candidate path output traffic to a set of segment list, while an SR policy composite candidate path output traffic recursive to a set of SR policies on the same head end. As shown in the right figure, the SR policy 100, which has a composite candidate path, referenced policy 1 and policy 2 by colors in the composite candidate path. As described in draft IETF PCE multipath, the PCE already supports distributing composite candidate paths. However, there is no similar mechanisms in BP SR policy. This document defines the extension for BP to distribute SR policy carrying composite candidate path info. Next page, please. SR policy with composite candidate path information is expressed as below. In the candidate path of an SR policy, constituted SR policy attribute subtheory is defined. This theory includes color, weight, and forwarding class. The color is used to reference the sub-SR policy, and the weight is used for loading balance. And then the forwarding class maps different type of traffic. Next page, please. The constituted SR policy subtheory has the following format. An optional single weight subtheory, which is defined in IDR SR policy, and an optional single per flow forwarding class subtheory, which is defined on this document. Next page. Here is a specific use case. The parent SR policy 100 has one candidate path, which is composed of policy A, policy B, and the policy C. It references these policies by color and map specific traffic to learn using forwarding class. Service with different forwarding class carry the different DSCP values in the packet. The voice traffic of VIP customers is forwarded according to the low delay path of SR policy A, and other traffic VIP customers is forwarded according to the path of SR policy B. and all traffic of non-VIP customers is carried by SR policy C. SR policy 100, policy A, and policy B, policy C can all be distributed via BP. When distributing SR policy 100, the sub policy A, sub policy B, and the sub SR policy C are referenced by the colors in the composite path. The forwarding class subtheory is used to map traffic with different DSP values to the suitable path. Next page. That's all. Thank you. Any question, comment are welcome.
This question is for Keaton. How does this composite relate to what you've done in the SR SAFI draft?
Ketan Talalikar Cisco. This would be an enhancement. So it is adding, let's say, a new functionality or new capability on top of that SAFI.
Thank you. Any other questions online or in the room? Okay, we'll go on to the next presentation.
Thank you.
Hello. Hello, can you hear me? Hi,
You're a
can you
lit-
hear me?
You're a little loud. Back off from your mic, please.
It's better?
You're still loud. Try reducing your volume on your set.
Okay.
If you could move your microphone, further from your face, that may help. Try that.
Okay.
Yeah.
No,
Okay.
further up. You're too quiet now.
It's better?
away from face,
Yeah.
but closer to your mouth, but away from your mouth.
Yeah.
You're that's what we're trying to fix.
Okay. Is that better now?
It's good enough. Thank you.
Good enough.
Okay. This is Feng Yang from China Mobile, and it's about time range wait for BGP SRv6 policy. Co-author is me and Chen Wangling from H3C. Next page, please. So why we do that? The motivation is some observations. The one is internet traffic model is gradually changing. With cloud computing, we notice that an increased amount of data needs to be transferred to cloud for processing. Examples including the intelligent vehicles, about 8 terabit of data for each road test car daily, and film production, and also some astronomical observations about 38 giga per second. So all of these applications are have some characteristics. The first one is data they transferred is quite large, and the second one is the all of the tasks are time bounded, requiring the network to transfer the data as quickly as possible. So the problem we noticed that current data network current one is the networking data center is quite is start to deploy the 800 gigabit technologies, whereas the wine area networks still rely on the 100 gigabit links. So there is the bandwidth is unmatched. So we rely on the ECMP and lag such kind of technology uh, to 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 meet the demands of the large data transfer from the data center to data center. Uh, when the uh, but the problem is that when the large amount of data transfer over the from the data center 800 gig data center to the 100 gigabit links in the one one links, the existing flow-based load balance mechanism may result in uneven pass load without properly scheduling of those kind of data transfer tasks. Uh, the congestion, some kind of congestion leading to the inefficiency and maybe sometimes the degraded service quality may happen. So so the simple idea is we proposed is to schedule a data transfer task and enhance overall transmission performance. Uh, we suggest that introduce a time-weighted attributes in BGP to preconfigure bandwidth resource allocation in network. Such, for example, we propose to have the time range attribute for the weight. So we can see in the bottom of this slides, we can see uh, at the beginning there are several flows from the B to C. One is over the bottom link, the other one is over the BAC link. So at the beginning, the BAC link is not fully fully utilized because there are another flow between the BA. And later on, if the BA's flow has been finished, then we can fully utilize all of the bandwidth between the BAC. So that's simple example just illustrate what we want to do with this weight, time ranged weight. So why we do that? It is because to what benefit we with uh, with a time ranged weight. The first one, I think that is quite will uh, makes our control configuration work uh, more efficient because uh, all of things has been done in advance. The other one is benefit is we will not rely on the SDN controllers while the all of the on the tasks run. So
You're
the last one, last page
you're running out of time. You might go to the uh, anything you want to cover in the subtlety.
okay, that's the last page is was the data format we proposed. That's all. I think.
Any comments, ideas? Caitlin's gone to the mic and so does Lijian.
Ketan Talalikar, Cisco. Question, there is work being done in the time variant routing working group, which also deals with, things, metrics and other characteristics in the routing protocols that need to be changed or tweaked as time elapses. Uh, is this work kind of along the same line? Would you agree?
Yeah, yeah,
So, I mean, if then just a feedback, maybe look at how it's being done there and try to kind of have an alignment, perhaps.
yeah,
Okay.
yeah.
Warning to people who are going behind Caitlin in the mic. AC, we're probably not going to get to you due to time. I suggest you send your comment to the list. John, as the AD, will let you go ahead, and Li Zhang will let you go. I'm sorry that we don't have more time. Go ahead.
Okay, thanks. Yeah, my question for the speaker was, or anybody who knows, is has this been talked about in spring already? Because my immediate reaction is when you start telling me that you're going to add weight to the segment list, et cetera, that sounds to me like a segment routing architectural question, and only secondarily a BGP protocol question. Thank you.
And Li Zhang.
Yes, Li Zhang from Huawei. And I want, based on your description in the use case, I want to know whether the data transmission time is can be predicted because you extend the SR policy with start time and end time. I want to know whether the data transmission time it can be predicted. Thank you.
We're having trouble hearing you. It's a little overrunning on the mic. You might also send your comment to the list. Thank you.
Okay, thank you.
Yeah.
Hi, can you hear me?
Loud and clear.
Good morning, everyone. It's a pleasure to be here. Today, I will be talking about extension of link bandwidth extended community. Next slide, please. To set the stage, let me first discuss the bottleneck of current BGP link bandwidth. BGP link bandwidth is now encoded in extended community attribute using 32-bit floating point type. There is a deviation in data type conversion. Thus, this mode is not user-friendly, especially when the routing policy is used for bandwidth matching. Next page, please. Therefore, to overcome this problem, we extend the link bandwidth based on 64 bits. A new type of IPv6 address specific extended community attribute that is considered to represent 64 bits link bandwidth. Meanwhile, we recommend considering both transitive and non-transitive scenarios. Additionally, only the format of link bandwidth has been modified in our document. The processing mechanism remains consistent with the link bandwidth document. At the moment, the subtype of transitive has already been assigned with a value of 6, while the non-transitive has not yet been assigned. The 64-bit link bandwidth is packaged as an 8-octet unsigned integer. The unit is bytes per second. The ASN stands for the autonomous system number of the router, which added the extended link bandwidth community. Next slide, please. From this table, we can clearly see the difference. First, the encoding is altered to IPv6 extended community. Then the transitive situation is added and the format is changed from 32-bit floating point to 64-bit unsigned integer. Next slide, please. As for the implementation information, the open source project FR Routing has implemented this draft. Next, please. Thank you for your attention. More comments and discussions are welcomed.
Jeff, you have the mic.
Jeff Tensor, NVIDIA. Quick comment, the problem statement is not entirely correct. The bandwidth community is not meant to encode the bandwidth available. It's meant to provide ratio between highest bandwidth available and lowest one. So I'm not sure you really want to encode exact bandwidth. You're really interested in the ratios because as you go down the system normalizing this value, it's not bandwidth anymore. So as you go through REAP, eventually into forwarding,
bandwidth is not interesting. That's number one. Number two, the functionality is widely deployed. There's millions of devices running this today. So updating it will require really serious considerations. And even so, there's for our implementation, practically it's used in a way as defined today. And if you want to change it, you need much more meat on the bones than what's in the draft.
Any other questions or comments? We will go to another presentation on link bandwidth. Reshma, you're up next.
Good morning, everyone. My name is Reshma, and I work with Juniper. I'll also be speaking about the link bandwidth extended community, along with Satya Mohanty, and on behalf of other authors. Next slide, please. Skimming through the agenda, as you know, this is a draft that already exists. We will see what is the current status of the draft, a bird's eye view of what are the works going on in this area. I would like to present the goal of this effort, then walk you through the proposed solution. We want to see what is the current trend existing and what is the next step for this effort. Next slide, please. Okay, so the link bandwidth extended community is a IDR adopted draft long since 2009, and it has expired since 2018. So this is an effort, it has been implemented but expired and not standardized. In this draft, the extended community is defined as non-transitive. That is, at an AS boundary, this link bandwidth community would be dropped. The current version of the draft, it does not go through all the use cases. It mainly speaks about the intra-AS case, how this bandwidth community is treated in an eBGP scenario has not been stated, or these use cases has not been discussed. So why are we discussing this again? The problem is different implementation have implemented this differently. So some implementation has used the transitive version of this link bandwidth community, and others the non-transitive version. So there's it has been deployed in both the versions, and there's an interoperability issue. Because of which the IDR chairs has requested the working group to look into it, and this is part of that effort to bring in interoperability. Next slide. So let's take a bird's eye view of what are the other work going on this area. So one of it is the EVPN-based solution, and which is presented in BESS. This work introduces a new transitive link bandwidth community, which uses a new format. And if you go through the draft, they explicitly say that one of the motivation for this draft to exist is that the transitivity type of the original IDR draft is non-transitive. Another work is the DMZ. So this works over the already adopted link bandwidth community. What the DMZ does is it aggregates the link bandwidth community on a particular router. And the draft talks about enabling knobs to accept as well as advertise the non-transitive link bandwidth community at a eBGP neighbor, at the border of an eBGP neighbor. So what this draft does is it uses the ambiguity in the 4360. So where it doesn't clearly state how a non-transitive community should be advertised at the eBGP border. The next is what we have already just heard from Lee. It also introduces a new format. MNH also carries the link bandwidth community. It has a per next stop scope, but that is out of our discussion now. Next slide. So the goal of this whole thing is, this effort is to achieve interoperability. We want to revive and keep the procedures simple so that when a receiver is updated, the code just interoperates with backward compatibility. The draft should cover all the use cases, inter-AS, intra-AS, is all we should state and see how it is covered. Define proper error handling and conflict management, and revive the existing draft. Next slide. In interest of time, I'm just going to just skim through this. I'm just flashing this. We can have a more detailed discussion over it, or we can come back to it. So we have discussed how a sender should behave. It should be able to, it should be a configuration driven of transitivity time. Receiver should be able to receive both the type of transitivity. Next slide. We prefer the lowest attached in case there are multiple link bandwidth community. We can discuss why later. And if there is the values are equal, then choose the transitive type. Re-advertising with next of self is same as a sender. So it's the same procedure without any change in next stop. It is less reflecting. So there should not be any change in the link bandwidth community. Next slide. Next slide, please. Jeff. Are we frozen? Next slide.
Yeah, I think the slide moved.
Current trend, sorry. So we see deployments that are both transitive and non-transitive. Juniper currently supports both the sending and receiving of both transitive and non-transitive link bandwidth community. We are also seeing other vendors incrementally supporting transitive and non-transitive version, and there are ongoing discussion on link bandwidth with a lot of vendors. Next slide. So what is the next step for this effort? So basically, like I said, revive the draft, modify the existing draft, make sure there's backward compatibility and interoperability, expand the draft to include all use cases. We also invite participation in this effort. We would like to request an interim if needed, to discuss the use cases and why the proposal idea is so. Or we can discuss it in the forum. We'll request other vendors to participate in a hackathon to demonstrate this interop, which will lead to the standardization of the solution. And also, like I said, 4360 bits, the extended community draft RFC should also have a clear indication how it should behave at the BGP border. Next slide. Thank you, and I invite questions. Yeah. Yes, Jeff.
Yes. So thank you, Reshma. Good presentation. Just as a brief clarification, the 4360 thing that Reshma is mentioning is that in general, the non-transitive non-transitive BGP extended communities, the procedure is unclear whether a router and an ASBR is allowed to throw it over the wall to the adjacent AS. And this is what's leading to some of the confusion out of the best working group. So while this impacts link bandwidth, it's not necessarily the only thing, and we may wish to actually look at a BIS document for this. Jeff.
Jeff Nansur, NVIDIA. So many of us here tried to rejuvenate the draft over the last 6 years with no success, right? And the real use cases went into cumulative drafts that's progressing in BIS for whatever reason, right? So my practical consideration, again, it's deployed at scale. The cumulative behavior is mandatory. Those are real use cases that are deployed. So building kind of two drafts in parallel, doing different things is counterproductive. I would rather the DMZ, the best draft to progress rather than trying to rejuvenate this one, because it's kind of proposing same thing that the other draft does, but trying to also adjust to initial draft. I don't think it's productive really. We should either merge and have one document, or use one that actually built on real requirements that is deployed. And again, it deploys in practically tens of thousands of devices today.
Yeah, so Jeff, hi everyone. Good morning from here. So essentially, that's the final goal, I think. Those two drafts will converge at some point. It's not independent. This has been a pain point for 10 years. And I do see most vendors, they are moving where they have the capability to send either as a transitive or non-transitive. And that's why that document was returned to us in the first place, right? So eventually that's the goal. So I'm in complete agreement with you. These are not competing drafts.
So as a user of this technology, my main goal is to avoid non-backwards compatible additions to the
Yes, that's why these the knobs are there, and this is something that has not been written down. This is just to bring to the audience whatever was written to us and how to work on that to
Yes.
make it compatible.
So practically we need to figure out what merges where. And again, I think the best draft has real use cases while this one is more abstracted and, so.
Okay, yeah, that one certainly has more.
I don't want two drafts to progress defining different problem space. It should be one document in one working group that is, kind of allows people to continue working on it. Thanks.
Sure.
I've got 2 more minutes for comment.
Kalaraj, you have a time for a brief comment.
Yeah, I just was trying to say that the current draft that we're trying to review, it's kind of more deployed. I mean, there are a lot of use cases. So we're trying to cover all the different use cases that are deployed, including the EVP and DMZ one. So it's good to have the standards document that got expired, revived, and incorporate all the different deployments, EVP and non-EVP, and the standard linking with connectivity that's used in the data centers for L3 IP forwarding. Thank you.
Thanks, Kalaraj. And Jeff, to your point, we do realize that reconciling the protocol work we're doing out of this document, or at least the intention to incorporate into this document, does need to be addressed with use case documents that are over in BESP. So we will be having a follow-up conversation with the BESP chairs about how to best reconcile all this work. The goal is to get the job done for everybody in a consistent fashion. Everybody already has this stuff in their network, and if you got more than one vendor, you already have problems, with this stuff. So we're just trying to solve it for everybody. Thank you, Reshma.
Thank you.
No, 10.
Hi, this is Chang Wanling. This draft is about the service metric distribution based on BGP in CAS network. Next page. So background in CAS network as shown in this picture, as described in draft IETF CAS framework. SIGA SMA is required to collect service metric. Routing in the ingress forward should be based both network and service metric. There are some problems with the CAS network as followed. First, the service metric period changed, unlike the existing routing information. Secondly, service are identified by CSID and CISID, and there are limitations in passing them through the existing address family. Certainly, the period update of service metric need to avoid impacting the existing routing. Thus, the period update of service metric required efficient mechanisms to improve the transmission performance. Therefore, based about the issues, we have the following thought. Use the extend BP to transmit the service metric. Leveraging the BP's efficient and powerful extension capability. We can also extend an independent address family to transmit the service metric without affecting the transmission of other routing information. We can define the flexible NRI to efficiently achieve the transmission of service metric. We can implement on-demand subscription to enable on-demand transmission of service metric. Next page. Let's take a look at the new address family. The NOI format of the service metric address family is TLV, and there are 3 root types defined, named type 1, type 2, and type 3. Type 1 represent the source metric registration route, which is include RD and CSID. Type 2 represent the source metric subscription route, which is include RD and CSID. Type 3 represent the source metric update route, which include RD, CSID, and the gateway also source metric. Type 3 route include both the key and the non-key data. Through this design, source metric route are embedded in a single BGP update message, enhancing the packing efficiency. Next page. This slide shows how the new service address family works. First is the registration operation. Egress node send the registration route to R, and R forward the registration route to all ingress node. Secondly is the subscription operation. Ingress node received a SOL request and send a subscription route to the R, and R forwarded the subscription route to the corresponding egress node, and the egress node respond and update the route to the ingress node. Next is the period update operation. Egress send period update service metric route to the subscriber. Last is the unsubscribed operation. When the forwarding table agent send withdraw subscription route to R, and R notify the corresponding egress of the node withdraw. Egress node no longer send period route update to the ingress. Next page, please. A summary of what the current solution has accomplished. First, we define a new BGP address family to dispute the computing service metric information. Include variable length NLI that distinguished between key and non-key paths. Metric that changed periodically are placed in the non-key path. Set the next hop for service metric route to 0 and place the service associated location address in the non-key path. We established the mechanisms for subscribing and publish service metric. The design goal is as follows: to minimize the impact on existing route advertised, and the service CSID identifier are not limited to any cast IP address. Thirdly, improve the efficiency of sending period service metric update. Lastly, we send on demand and control the propagation scope of service metric. Next page, please. Finally, let's take a look at a specific use case of service metric advertisement. In this case, two service instances of the same communicating service are located at the gateways of two different egress forwarders. User data is sent to the best service instance based on the metric information at the ingress forwarder. 1 and 2 represent the registration operation of the service by egress forward 1. And then 3 and 4 type 1 route represent the registration operation of the service by egress forward 2. 5, 6, 7 represent the metric subscription operation of the service by the ingress forwarder. 8 represent the metric update operation of the service instance 1 by egress forwarder, which is sent to the R device. And the 10 represent the R received all service metric update route and forwarding them to the ingress forwarder. When R sends, it will pack the route with the same attribute together to efficiency improve the sending efficiency. That's all. Thank you. Any question, comments are welcome.
Any questions in the room? Okay, Changwan, we don't have any questions in the room. Thank you for your presentation.
Yeah, thanks.
So as a final reminder, if you have not scanned in for the QR code, please do so that we could actually get a room of an appropriate size. I think this takes us to our final presentation for the day.
Hi everyone, can you hear my voice?
Hello, we can hear you.
Okay, before I start, I need to make it clear that there are some problems with my IETF account and I cannot log in, so I temporarily borrowed this account to give a speech. I'm Penfei Huo. I'm glad to share this draft for you. BGP extension for terminal egress point. Next slide, please. In general, AI training may have fewer flows, but most of flows are elephant flows with a strong burst, so it's easy to cause network congestion when using traditional like untapped load balancing methods. Currently, the direction of traffic scheduling focuses on load sharing individual packets of the same flow, which requires reordering based on the terminal egress point information from the remote end. So this document describes the method of publishing terminal egress point through the BGP protocol. Next slide, please. Actually, some chip manufacturers have already provided non-Ethernet method, which effectively addresses the challenges encountered in AI application scenarios, and it well meets the technical requirements of AI of sorry of AI network architecture in terms of data forwarding. This article introduces an implementation scheme that uses this non-Ethernet method as a form of terminal encapsulation for Ethernet packets. We refer to this network architecture as Open Scheduled Fabric (OSF). There are two important parts in this slide. First is about OSF framework. There are two rules in OSF framework. One is the forwarding node, and the other is the encapsulation termination node, which we call the OSF forwarder and the OSF ingress egress router. A second part is about control plan. Ingress and egress nodes will establish BGP neighbor and transmit the necessary encapsulation information for the OSF forwarding layer. Next slide, please. It's a quite this slide has lots of content. So let me take a brief introduction for outbound interface information and data packet encapsulation information. In an OSF network, data forwarding involves processes such as slicing, authorization, and reassembly with multiple devices playing different roles, including encapsulation nodes and forwarding nodes. Uh, and Ethernet data packets are segmented into several equally sized data streams and transmitted in a spree-like manner within the OSF architecture. This approach addresses the issue of load balancing, but it introduces sorting issues in the process of resembling the data stream into Ethernet packets. To resolve the sorting problems, the inbound encapsulation node needs to allocate sequence numbers to the packets based on the outbound encapsulation node interface information. This allows the outbound encapsulation node to resemble the data streams into Ethernet packets using the unique sequence number information associated with each interface. This requirement needs the extension of interface information in the routing information as part of the encapsulation information within the OSF system central plan. The outbound interface information consists of two parts, the device ID and the port ID. For uh, for data packet encapsulation information, when the data plan adopts non-Ethernet technology, the packets needs to be converted into an Ethernet packet at the this device needs to assign a local ID to its own local Ethernet encapsulation information and pass it to other devices through control protocol. Meanwhile, the encapsulation device will carry this ID in the header information of each non-Ethernet packet, allowing the de-encapsulation device to quickly locate the encapsulation information based on the packet header information. Therefore, the control plan needs to be extended to carry an encapsulation information ID to all end devices. These IDs only have practically significance on the producer. Next slide, please. In order for a network host to achieve data communication through the OSF network architecture, we choose BGP EVPN as the control plan by extending the EVPN internal encapsulation tabs. The necessary encapsulation information for OSF forwarding is synchronized across the entire network, and communication between hosts is done through tunnel forwarding, similar to tunneling, rather than hop-by-hop IP forwarding. Add a new tab, TEP tab, to BGP tunnel encapsulation attribute tunnel tabs. Next slide, please. Here's a layer 3 communication example. Establish full mesh BGP neighbor relationships among leaf nodes. As we can see, leaf 4 collects local routing information and outgoing interface information, synchronizes routing information to other BGP neighbors, and then leaf 1 will generate the tunnel route. Next slide, please. In this slide, we take a brief introduction for layer 2 communication example. Actually, mic learning and mic table synchronization. Leaf 4 learns the MAC address of host 2 in the Ethernet forwarding domain and synchronizes it to other nodes through BGP EVPN tab 2 route, while carrying the necessary encryption information for the OSF network. Just like I said, the device ID and the port ID. Then leaf 1 will generate the layer 2 unicast table or layer 2 unicast route. Then how to establish a broadcast domain? We will utilize extend EVPN tab 3 routes to include new attribute include a new attribute carrying broadcast member port information, allowing devices to determine which egress interfaces need to replicate broadcast packets at the ingress encapsulation node. For example, host 1's broadcast packet is matched in the broadcast table on leaf 1 device, and leaf 1 replicated to the broad domain. Next slide, please. And here are some progress or running code. Hardware and software development is underway with plans to conduct interoperability testing in BadDance Live in 2024. Yeah, next slide. This is the last slide. Any questions or comments? We will continue improving the OSF network architecture.
Hey, Keyur Patel, Arcus. This is somewhat interesting work, speaking as a non-work, just as a working group member. We have been working also, and we have a document in process, but the way we are doing is a little different from what you are doing. So would love to connect and make sure if we can converge on a single document.
Oh, yeah, it's cool. Thank you so much.
Just answer NVIDIA. I think you should clarify motivation in your document. The reordering of packets is function of the receiver, not of the switch that is in the middle. You cannot do it in the switch, simple as this, especially if traffic is encrypted. Your statement that packets need to be reordered before fed into application layer is incorrect. It's an RDMA packet. If you're talking about AI traffic, each packet has a pointer to location in the memory. So practically you can place it without reordering. It's widely implemented. With regard to what you're signaling, you said it could be either unicast to type 5 or type 2. All you need to know, you already know. You need to know outer encapsulation, which in most cases, VXLAN, could be Genève, could be something else. So practically the information already there. The rest belongs on the NIC and the host. It has nothing to do on the switch. So your motivation is not very clear, and reading it, it's not clear. You're trying to do something on the host, you're trying to do something on the switch, and how. So please clarify what you're trying to achieve here.
Any other comments? Well, we've hit the end of our time, just about on time. Thank you, everyone. We will have a session on Friday. It is the last session of the day. Join us at that time. The only benefit is after the session, supposedly there are goodies in a goodbye meeting. We will also have online. So if any of you are in the middle of the airport, join us that way. Thanks again. Bye-bye.
exactly in time. Jeff, use the cue.
Please, you didn't.
He's special.